Okay, so we are doing number 2 from this practice test worksheet thing I gave you yesterday. Let's mark some stuff. That side is 2x minus 3. This one is x plus 5. This one is 2x minus 7. And this is x plus 1. And that's a D, that's C, that's A, and B. I think that's everything, isn't it? That's a D. Yep.
No, the other one.
Oh, what did I do that for? It's a B. How's that? All right. What does it say? It says the perimeter of ABCD. Now watch it. It's A, B, C, D. So it's actually quadrilateral, isn't it? You see that? I'm not going to shade it in, but watch from here to here to here. Now it doesn't just stop here; it goes all the way to there. That would be quadrilateral ABCD. It says the perimeter is 44. I'll just put P equals 44. Well, what does it mean to find the perimeter of something? Right, add up all the sides, right? So I've got these 4 sides, so what am I going to do? I'm going to add up all 4 of these sides, and then do what to it? Divide it by 44? Set it equal to 44. That's right, because all 4 of these things add up to equal 44. Everybody see that? So when it says the perimeter is 44, that means all 4 of those sides adds up to be 44. So let's do that real quick. Doesn't matter what order we add them. We'll go x plus 5 plus 2x minus 7 plus x plus 1 plus 2x minus 3. All that adds up to be what? 44. Now we should be able to do some algebra, right? And then solve for x. So let's do that. Let's add up the like terms first. I got 1x plus 2x, which is 3x, plus 1x is 4 plus 2, which is 6. So it's 6x. Everybody see that? When I have a whole bunch of these things and I've already added them up, I like to get rid of them so I know I'm done with them. All right. Now let's add up the regular numbers. 5 minus 7 is negative 2, plus 1 is negative 1, minus 3 is negative 4. And that equals 44. Now we just continue solving for x. We add 4 to both sides. So 6x equals 48. And then divide both sides by 6. And so what's x equal to? 8. And there it is. That's what x is equal to. All right, you with me on that? Then it says describe the relationship between AC and BD. There's a theorem that we talked about. I think it was like in section 5.1 or something like that. It was way early. That said, I forget exactly the wording of it, but it said if a point is equidistant, or what did it say, Christian? Where did we get that? Do you remember? Let's do this. Let's see what this distance is. X is 8, right? So x plus 1, that would be what? What's DC? It's 9, right? What's this? 2 times 8 is? 16 minus 7 is what? It's 9. So this point right here is equidistant from the endpoints, isn't it? What about this point A? What do you think is true about these 2 lines? They're probably equal to each other, right? But let's stick the number in and see if it is. So 2 times 8 is 16 minus 3 is 13, right? Let's put it 8 in here. 8 plus 5 is what? 13. So that's the same distance. So we had a theorem. If you look back on it, I don't know exactly what page it is, but if you look back on it, Zary, you better wake up. Your dad's outside the door. So look at this right here. This is equidistant from the endpoints of this line segment. Okay, we have a theorem that says if you have a point that's equidistant, what it does, it lies on the perpendicular bisector. That means this line right here, AC, all right, it's perpendicular to it and it bisects it, so that and that are equal to each other. All right, so it's a theorem. Look back, flip the page. I'm not sure exactly what page it's on, but you'll see something like that, where if it's equidistant from the endpoints, then it lies on the perpendicular bisector. Okay, does that make sense? All right, and that's one we haven't talked about in a really long time, probably before Christmas break. So Christian asked me about it yesterday, and I even had to look it up because I forgot myself. All right, so you may want to go back and look at it to see what that says. But really, on a test, if I gave you anything like this, I would probably just ask to solve for x. We good with that? All right. Let's do another one. You got another one in mind? Get rid of all this mess. Anything else? It's got to be something else, right? What about 3? Nobody's asking, but I have a feeling that's probably one you want to ask about. Well, some people would. Okay. Triangle looks something like this. Alright, then we had some... Now, it says if point E is the centroid. Now, how did we find the centroid? Do you remember that? There's a chart. Somebody look it up for me. What page is that chart on? Joel, you got your book open. Where's it? Wrong book. Got your Spanish book open? Is that chart in the Spanish book? Okay. There's a chart that has centroid and circumcenter and incenter and all that stuff. What's that? It's in the book though, so find it. It's chapter 5. Just flip around. It's like section 5.2 or something like that. There's a big old chart with all those things. Remember? There it is. What page is that? 337. So if you look at page 337, it tells you a bunch of stuff. What does it say, Joel, since you're there? What does it say about the centroid? What do you do? What do you find a perpendicular bisector? Do you find a median? Do you find an altitude? Do you find an angle bisector? What do you find in order to find the centroid? What's that? Under centroid? Yeah, that's right. It is the median. I was trying to remember myself. Okay, yeah, it is the median, right? Is that what it says? Yeah. Yep, there we go. So if we find the median, how do we find the median? We go from the vertex where? Where do we hit? To the midpoint of the opposite side. That's right. I'll tell you what, let's get rid of that. I just want to see this. Okay, that's where the middle is, right where that dot is. So I'm going to start here and go to there. All right, so that is the median. Let's do the side right here. So let's see, if I go across to there, that's probably the midpoint, right? To there, and then I got to do one more, and that would be what, this side right here? So let's find the midpoint of this side. If I come straight across there, that's probably it. And then, there we go. Look at that. It's pretty close. Not exactly, but it's not bad. Alright, so it meets right there. So that's the centroid. So how did we find the centroid? We found the medians. Okay, what's the median? The median goes from the vertex, where? To the midpoint of the opposite side. So from this vertex to this midpoint, from this vertex to this midpoint, doesn't look like I really started the vertex there, but that's okay. From this vertex to this midpoint. If I find that, this point right here is called the what? Centroid. Like, okay, you got to know that in order to do this thing. Zaria? That's unacceptable, okay, that you have your eyes closed. Come on, let's pay attention. Sit up straight. All right. So this thing right here is the centroid. Do you remember what the deal is with the centroid? Remember this segment right here and this segment right here? Yeah, this big segment from the vertex to the point, how much is it? It's double the other one, exactly right. So this one right here is double this one right here. Or you could say that the short one is what? Double the, I'm sorry, the short one is half of the longer one, okay? Or you could say that the longer one is what of the whole thing? 2/3. Or you could say the shorter one is what of the whole thing? 1/3, okay? There's all kinds of ways to look at it, isn't there? All right? So let's go back to the problem. BD is 12. So watch, from here, oops, that was kind of ugly. That's all right, that works. From there to there is 12. So that whole thing, we'll call it BD, is 12. And what else do they tell you? EF is 7. So from here to here is 7. That's F. That in the middle is E. That's C. This is A. And this is G. All right. What else? They tell you something else. AG is 15. AG. Wow, it's getting a little ugly, but we'll try to fit it all in there. So this whole thing is 15. Thank you. All right, let's see what we can do now. Let's find all these lengths, all the lengths that we can. Look at BD first. From B all the way to D is how much? It's 12. Now remember, the shorter one is how much of the whole thing? It's 1/3 of it. So I just take 1/3 of 12. Or 12 what? Divided by 3. So what's 12 divided by 3? That's 4. So this little bit right here from E to D is 4. Right? What is it from B to E then? If the shorter one is 4, what is the longer one? It's going to be 8. It's twice as big, isn't it? So if the shorter one is 4, then that is 8. That's the easiest way to do that. Does that make sense to you? So if they give you the whole thing, find the short one first. How do you find the short one? Divided by 3. Okay, it's 1/3. It's not half, it's 1/3. So you divide it by 3. How do you find the longer one of the two? You double the short one. Okay, so 4 times 2 is 8, and that's going to be 8. Everybody got that? So we should be able to do the same thing with AG. Look, AG, the whole thing is 15. Let's find the short one first, which is from E to G. So from E to G is how much then? The whole thing is 15. What's the shorter one? It's 5. How'd you get 5? Divided by 3. Same thing as we did with the 12. Okay, you take the 15 divided by 3, which is 5. So from E to G is 5. What is it from A to E then? It's going to be 10, right? Because remember, the longer one is twice as big as the shorter one. So that's going to be 10. Remember that?
Yeah.
Okay. So you got to go back and look. What I would do, out of all the lessons, if I was going to review any of these lessons from this chapter, I'd go back to section 5.2. I think, Joe, that's 5.2, right? Where that chart is. Look at the bottom, it'll say.
Yeah.
Okay. So I would go back to section 5.2 and watch the YouTube videos. Okay, watch the whole entire thing. It's probably broken up into a couple different videos, but take some time and go over them so you know which one's which. I mean, I have trouble remembering myself, all right, and I'm teaching this stuff, all right? So you've got to go back and you got to study it, watch the videos, and take some notes on it, or have your notes that you already took out in front of you or something like that, and make sure that you know the relationships between all these things, all right? Does that make sense?
Yeah.
All right, enough of that. What's another good one? I know number 9, there was a lot of questions about number 9 yesterday. So as you're looking for another problem that you weren't sure how to do, I'll go ahead and do number 9. And let me draw this thing. So it looks like that. Doesn't have to be exactly to scale, does it? We're just going by the measurements. Looks like something like this. That's pretty close. So watch, this is 65. These are all degrees. I'm just not going to put the degree symbol in there. It gets a little squished. That's 55. This one's 60. Up here is 65, and this one is 55. Alright, so we've got X, Y. Down here is W, and this is Z. Alright, it says, find the shortest segment. Alright, everybody paying attention? So let's take a look at this thing. Let's first of all just look at the left triangle, XYW. Everybody see that? Forget this triangle over here. Just look at this triangle right here, XYW. How could we find the shortest segment, the shortest side of this triangle? What do we look for? Do we just look and measure it? Do we take a ruler out and we say, oh, this one's the shortest one? Smallest angle, that's right. So which one's the smallest angle? 55. 55 is the smallest angle. That's 65, that's 60, this is 55. That's the smallest one. So where do we look to see which one's the smallest side? Opposite. So XY, okay, is the smallest side on this particular triangle. Everybody see that? So XY, right there, I'll kind of just darken it in a little bit. XY is the shortest side on the left triangle. Make sense?
Yep.
Okay. Let's go to this triangle right here. And let's find the shortest side on this right triangle, YWZ. So we got 65, 60, and 55 again, don't we? All right. So 55 is smaller. Where do we look? Opposite. So what's the smallest side on the right triangle? On the triangle on the right, I should say. It's not a right triangle, but it's the triangle on the right. It'd be YW, wouldn't it? Okay, so on the left triangle, XY is the smallest side. On the triangle on the right-hand side, YZW, then YW is the smallest side. But does that mean just because they're both opposite 55, they're equal to each other? No, it doesn't. All right, because look, I could have a small. I'm not even going to go through it. I was going to, but I'm not. It doesn't mean that they're equal to each other. Look, what am I comparing now? I'm comparing this side xw to this side yw, or sorry, xy to yw. Which one's bigger? Which one's smaller? Is it this one or this one is smaller? Well, look, this is also part of this left triangle. What did we say? I already said out of this triangle on the left, which one was the smallest? The xy has to be smaller. So the xy is still smaller than this yw, isn't it? All right. So xy is the smallest out of the two. So xy is your smallest side. Does that make any sense? Okay, because we figured out this was the smallest side of this triangle. This right here was the smallest side of this triangle. But now I got to compare the two. But you're looking at it and you're like, well, wait a minute. Those two sides are in the same triangle, aren't they? So let's look at this triangle again. Which one did I say was the smallest out of these three sides? XY was the smallest out of these three sides. So XY is the smallest out of this whole entire thing. Does that make any sense at all?
Yeah.
Okay. It's a little hard to explain, but I think it made sense to me anyway. I don't know if it made sense to you or not. Hope it did. All right. We good? Did you find another problem that you might want to ask about? You got two sides to this. XY is the smallest side out of the whole thing. It's YW, yeah, it's the smallest side out of this triangle right here, and it's the smallest side out of this triangle too. Yeah, it doesn't matter though. Here, I'll show you that. This is what I was gonna do, and I'm just gonna do this real quick. Watch, copy paste. Watch this. Let's just make up some stuff. Let's say that's what, 65. Let's say that's. Let's make this a little easier. Let's say it's 60. Let's say that's 40. No, that wouldn't work, right? Sorry. That looks a little steeper. Let's say that's 80 degrees right there. Okay, so if this is 80 and this is 60, what's this right here? That's 120. So it'd be, yeah, I'm not liking this. Let's make this, sorry. Sometimes I just go too far. I don't know, let's say this is 70 and this is 80. That's 150, so what's this? That's 30. That looks a little bit better, okay? So now let's take a look at this. Just because it's opposite the same angle doesn't mean that they're the same size. All right, just because this is opposite 55 and this is opposite 55 does not mean that this length and this length are the same. Let me show you why. Hopefully this will make sense to you. Because watch, I could take this triangle. Now I hit the shift button. Now hitting the shift button on this program means that I didn't change the shape of it. I just changed how long the sides were. So guess what this angle is? That's 70, right? Guess what this one is? That's 30, and guess what this one is? That's 80. Over here, which one's the smallest side over here? It'd be this one right here, wouldn't it? Okay. Which one's the smallest side over here? It'd still be this one, wouldn't it? But look, does that mean that this side is equal to this side? They're both opposite 30 degrees, aren't they? Okay, but they're not equal to each other. Makes sense? It's the same thing here. This is opposite 55. This is opposite 55. But does it mean that they're necessarily equal to each other, the lengths of those sides? No. All right, because you could have a smaller triangle and a bigger triangle. So now what I'm doing is I'm comparing these three, and this has to be smaller than this because in this triangle, that's the smallest side. Does that make sense? So just because it's opposite 30 and just because this is opposite 30 does not mean that these two are equal to each other. Just because they're opposite the same angle, right? Because that's way bigger, wouldn't you agree? That's way bigger than that. If you don't believe me, I'll just take it and scooch it over and we'll look at it. See? This side right there is way bigger. It's still opposite the same angle, okay, but it's way bigger than this side right here. All right, I think I killed that enough, don't you? Is there something else that you want to go over? Remember, you'll see some stuff like this on the test. So if there's something on here you have the slightest doubt about, you should be asking me. Emily? Like from smallest to largest? Is that what you're talking about? Or is there a particular one of those? Like when you're comparing two triangles to each other? Like 16, probably. Let's do 16, and then if you find another one that you would rather do, then let me know, okay? But we'll do 16 for right now. Just try to eyeball this. Okay, that's close enough. We'll call this, well, that should touch right here, but use your imagination. G. Alright, and this little angle right here is 20 degrees. This one down here is 23 degrees. This side is 6, and this side is 6. Alright, and it says compare side EF to GH. Alright, so when it says compare the two sides, what are they asking you to do? Are you trying to find the measurement of these sides? No. When they say compare them, what are they asking you to do? I've talked about this quite a few times. Right, greater than or less than. Is EF greater than GH or is it less than GH? Okay, that's what we got to find out. Okay. Now, you could just guess, but what's your chances if you guess? 50-50. Okay. 50-50. All right. So, but do you want a 50% chance? No. What would you rather have? 100% chance. So let's go through and let's take a look. Look, I've got this side equal to this side. I've got this side equal to this side. So look, 20 is smaller than 23, isn't it? You see it? So what do I look at? I look opposite. So EF is opposite 20. What's opposite angle? This angle right here? GH. So if EF is opposite 20 degrees, it has to be what? Smaller than GH. Right? Because the side opposite the smaller angle is smaller than the side opposite the bigger angle. You get it? All right? So this side right here has to be smaller than this side right here. Now you can't just look at it and tell, can you? All right? It may not be drawn to scale. It might be drawn to scale. Even if it was drawn to scale, sometimes they're so close you can't even tell. So you got to go by the numbers. So the side opposite the smaller angle is smaller than the side opposite the bigger angle, right? So this is opposite 20, so that's smaller, right? This is opposite 23, and that's bigger. Make sense? All right, so what do I say about EF? I don't write small and big. What do I write? Less than. I write EF is less than GH. That's how you would write your answer on the test or a quiz. You got it? Now, we're not going to have a quiz on this because we're just taking the test on Tuesday, but on the test, that's what I want you to write. I want you to put EF, and I want you to put GH. Don't just put in less than symbol. Everybody understand me on this? So if I say compare the two, on your answer sheet, don't just put less than. I want to see EF is less than GH. Everybody got that? Okay.
What about if they give you two triangles, but they just give you the length of the sides? And they don't ask you to compare, they just ask you to find the biggest measure. Like on the quiz.
They'll ask you to find the greatest measure of the, like which one? On the quiz? Which number?
4 and 5.
4 and 5? Okay, let's do that. Everybody in here did take the quiz, right? Okay.
Oh, no.
All right, so let's do this is from the quiz then. Yeah, I'm allowed to go over 15 now, remember? Yeah. YouTube's nice to me, and they said I could go over 15 minutes. I don't know. I've gone up to a half an hour. So, I haven't gone any longer than that. Come on, at home they never canceled school because of snow, did they? Well, why would they do it here? Come on. All right, let's take a look. What do they ask you to do? They say find the smallest angle in triangle VUW. Now, some of you guys were not using the right triangle. It says find the smallest angle, okay, in triangle VUW. I said W and I wrote an X. How dumb was that? I said W and I wrote X. What was up with that? Okay, so VUW. Find the smallest angle. Where's triangle VUW? VUW. It's this triangle right here, okay? So look, I know 3 sides. I know 9, 9, and 5. I want to find the smallest angle. So I look for the smallest side. The smallest side is 5. And then I take that side and I look where? Opposite. So it's this angle right there. Now, I did let you say angle U because I did say triangle VUW, but technically you really should say what? Triangle what? Or sorry, angle VUW.
So when it says measure it based on the angle.
It says find the angle with the greatest measure. Okay, so there's no debate on what you're trying to find. Okay, it says find the angle with the greatest measure. So you're trying to find the largest angle in that triangle. Now the next problem says find the angle with the greatest measure in triangle UWX. Everybody watching? This triangle right here. We're trying to find the greatest, not the smallest this time. Trying to find the greatest measure. Okay, or angle with the greatest measure. So we're looking at this triangle. I'm only looking at this triangle. I had some people giving me like angle V for an answer. Angle V is not even in this triangle. Okay, so that doesn't make any sense at all, does it? You got to think about when you put your answers down what makes sense and what doesn't make sense. Look at this triangle right here. I can only use the angles in that triangle. So we're trying to find the greatest measure. So we look for the side. That's the what? That's the greatest side, the largest side. Which one is it? It's 9. So if I take 9, and where do I look? I look across from it, don't I? Okay, I look across from it, and it would be this angle right here. Now, I could just call this angle X, because there's no other angles coming out of that. So I could just call it angle X. So angle X is your answer for that one. Make sense? Okay. Now, I let you say angle U on this, but technically you probably should say VUW. On this, you can just say X, and it's fine.
You corrected mine, and you wrote like
Right.
angle
But I still gave it to you, though, right?
UW, but then at the bottom it's angle X.
Right. On this one, you can say angle X because there's no other angles. Like right here, if I said angle U, you don't know if I'm talking about this one,
Oh, okay.
this one, or the whole thing, right? So you got to be more specific when there's more than one angle coming out of that vertex. Like right here, that's the only thing. That's the only angle with X, so I can just call it angle X. Like angle W, I couldn't just call that angle W, could I?
You have the whole thing.
Yeah, I got to say either UWV or XWU.
But if it was V, you could just say angle V.
And right, with V, I could just say angle V and nothing else, yeah? All right, we good with that? Anything else? All right, I'm going to give you a little bit from the book, okay? Sorry, but we need to do as much practice as we possibly can. So this is for your benefit. Don't you hate hearing that? When you're a kid and your parents spanked you, didn't they say that this is for your own good? It's because I love you. It's for your own good.
Yeah.
But it's... But this is for your own good, okay? Hopefully this is not like a spanking, hopefully. So watch. All right, here we go. All right, you guys are all wound up. Listen up. Shh. Look, I could give you all of them or I could leave some out. Do you want me to leave some out? Well, listen to which ones are left out then. Quit talking. Okay, so I'm going to leave out. Omit means leave out, okay? So leave out number 5. 17 through 19. So 17, 18, and 19. It's page 381. And number 23. You should be able to do all of them, okay? So write those down. You do not have to do 5, 17, 18, 19, 23. Right? It's page 381. It's called practice test. It's called practice test. That's homework. It's due Monday. Everybody write that down?